A baby insect is born into a brutal world. No mother standing beside it. No father showing it where to go. No teacher saying, "Don't eat this leaf," or "Run from that smell." It enters life alone. And somehow, it survives. That sounds normal because we see insects everywhere. But when you really think about it, it becomes strange. A human baby needs years of care. A puppy needs its mother. A bird learns from the nest. But many insects are born, crawl out, and instantly enter survival mode. They have to find food, avoid poison, escape predators, choose the right place to grow. And sometimes, they have only days or weeks to figure it all out. So here is the question. How does something with such a short life, and almost no parenting, already know what to do? Is it instinct? Is it learning? Or is nature doing something even stranger? Can insects somehow pass survival lessons to their children before they are even born? This sounds like science fiction, but one real story begins with a young boy in Japan. His name was Joe Nagai. Joe was fascinated by butterflies, not just because they looked beautiful, but because he was curious about something deeper. What does a butterfly remember? That question is already strange because a butterfly does not begin as a butterfly. It begins as a caterpillar, and a caterpillar is almost like a completely different creature. A caterpillar crawls, a butterfly flies, a caterpillar eats leaves, a butterfly drinks nectar, a caterpillar spends its life chewing through plants, a butterfly spends its life searching for flowers and mates. And between those two lives is one of the strangest transformations in nature: metamorphosis. Inside the chrysalis, the insect's body is rebuilt, its shape changes, its lifestyle changes, even its nervous system is reorganized. So for a long time, people assumed that if a caterpillar learned something, that memory would probably vanish when it became a moth or butterfly. Because how could a memory survive that kind of transformation? It would be like remembering your childhood after your entire body was taken apart and rebuilt. But scientists tested it. In 2008, researchers trained caterpillars of the tobacco hornworm moth to avoid a particular smell. They paired that smell with a mild electric shock. After training, the caterpillars learned one simple lesson. This smell means danger. Then came the real test. The caterpillars transformed. They became adult moths, and when the scientists tested them again, the moth still avoided the smell. The lesson had survived. The caterpillar had become something new, but some part of its old experience remained. That is the first twist. An insect can learn something as a young form, transform into an adult form, and still carry that warning forward. But scientists wondered something even bigger. What if the warning did not stop with the moth? What if it could reach the next generation? Imagine a moth that learns a certain smell is dangerous. Then it lays eggs. The babies hatch later. They never met their parent. They never saw what happened. They were never trained. No one taught them anything. And yet, what if they also become more careful? That is where the story becomes almost unbelievable. But before we go too far, we need to be careful. This does not mean insects are passing down memories like a movie file. The baby insect is not born with a full video of its parent's life. It is not thinking, "Ah, yes, my mother once had a bad experience with this smell." That is not how it works. What may be happening is more subtle. A parent's experience can change the parent's body. Stress can change hormones. Danger can change behavior. The environment can affect eggs, sperm, and chemical signals. And sometimes, those signals may influence how offspring behave. So the child may not inherit a memory. It may inherit a bias, a tiny survival setting, a warning written in biology. Not "I remember what happened," more like, "Be careful around this. Choose that food. Avoid that place. The world may be dangerous." And one of the clearest examples comes from fruit flies. Fruit flies have a nightmare enemy, parasitic wasps. These wasps lay eggs inside fly larvae. Then the wasp babies grow inside them and eventually kill them. So when adult fruit flies see these wasps, they change their behavior. They start laying eggs in food that contains more alcohol. That sounds strange, but for fruit flies, alcohol-rich food can help protect their larvae from the wasps. So the fly sees danger and changes where it puts its children. That already feels smart. But then researchers found something even stranger. The offspring of these wasp-exposed flies also showed a change preference, even when they had never seen the wasps themselves. The danger signal echoed into the next generation, not forever, not like a permanent superpower, but for a few generations the effect could remain. Think about how powerful that is. A tiny fly sees a threat. It cannot sit with its children and explain the danger. It cannot say, "Listen carefully, there are wasps outside, lay your eggs somewhere safer." It may never even meet them, but its body can still leave behind a kind of warning, a message without words, a lesson without a teacher. And this changes how we think about learning, because learning is not always a classroom moment. Sometimes learning is a brain remembering pain. Sometimes it is a body reacting to stress. Sometimes it is a parent choosing a safer place for its eggs. And sometimes it may be a tiny signal that reaches the next generation before life even begins. That's what makes insects so strange. They do not survive because they have one trick. They survive because nature gives them many small tools at once. We usually imagine learning as something big. A brain, a classroom, a parent, a long childhood, a lot of time. But insects do not have that luxury. Their world is fast. Their childhood is dangerous. Their lives are short. So nature gives them different tools. Some things are instinct, shaped by evolution over millions of years. Some things are learned during their own life, like avoiding a smell that once meant danger. And some things may be influenced by the experiences of their parents. That is why insects are so fascinating. They are not simple in the way we imagine. They are small, yes. But small does not mean stupid. A caterpillar can learn. A moth can remember. A fly can respond to danger. And sometimes the next generation can be born already slightly prepared for a world it has never seen. This is not magic. It is biology. And biology is often weirder than magic. Because a human parent teaches with language. A bird parent teaches with behavior. A wolf teaches through the pack. But an insect may teach through chemicals, choices, and inherited signals. No bedtime story. No warning speech. No family lesson. Just a tiny message hidden inside life itself. Something dangerous was here before you. And maybe that is why insects survive so well. They do not need long childhoods. They do not need parents standing beside them. They are born into a world already shaped by millions of years of trial and error, and sometimes maybe even shaped by what their parents experienced before they were born. So the next time you see a tiny insect crawling alone, don't just think, that thing is simple. When we look at an insect, we usually see something tiny and insignificant. But inside that tiny body are millions of years of evolution, instincts shaped by countless generations, and sometimes even subtle traces of what came before. Nature has been solving the same survival problem for a very long time. Think about what it may be carrying. Instinct from ancient ancestors, lessons from its own short life, and maybe a warning from parents it never met. No parents, no teacher, almost no time, and still, it survives.